So the platform itself is really broken into three different levels, and it's kind of a staged process of how we initially process the drawings, get them into the system, make them intelligent, and then tie in other information to this. So if we look at those three levels, the first one is what we call the smart register. And so that's where we, again, take the drawing, process it, and put it into our database structure. And once it's in that database structure, we're able to gain insight immediately on, the master equipment lists inventories that we see in there. So we look at symbol definitions inside of that, and we recognize what valves are, what instrumentation is, what fixed equipment tagging looks like. And so we generate all of that information as far as the inventories that exist inside of the drawings. Metadata extraction involves gaining any other insight and information we can from that. So when we look at a CAD format, in some instances, you can have additional metadata or attributes associated to it. And that would be something like you see a block for an equipment information tag at the top or the bottom of a typical piping and instrumentation diagram. You see information like design pressures and temperatures, flow rates for pumps, information like that. That's the other side of the metadata extraction, where we can take that information and actually associate it to the assets on the drawing. So not only are we getting an inventory representation, we're gaining some insight into what that asset is. At that point, we go through asset classification, and again, recognizing the different symbologies in order to properly classify and structure those assets inside of the drawing. And the last one there, the relationships, is really the key one. So this is how we go from a dumb CAD drawing to an intelligent drawing inside of our system. It's understanding the connectivity in between the assets, where you see process piping connected out from a vessel going through a pump and into a tank, as an example. We understand those flow directions, we understand those connectivities, and that's really the basis for introducing the intelligence into the drawing to begin to do things like energy control pans and product transfers. And I'll be showing some examples of those as I go through the presentation. That second level of visualizing and contextualizing data from the takeoff and other data sources means being able to, again, something as simple as generating the inventories from it, but understanding if I had a product transfer as an example, and I had a certain line list and a source and a destination from that, being able to map that out and actually what we call distill it down into a single drawing. So you might have a product transfer that occurs across multiple different P&IDs, but we can actually extract that information and distill it down into a single drawing. Visualizing information by recoloring the drawing to indicate, as an example, risk. We can change the colors of the assets on the drawing in order to reflect data that's being fed into it. The third level is really building out API-rich ecosystems. And so here we're talking about having all of the inventory on the drawings, understanding what that inventory is based on tagging and nomenclature, and then being able to go out to other systems and bring in additional information about those assets. An example might be a CMMS system like SAP or Maximal, being able to go out, pull inventory information or pull work order information about that. It could be an inspection data management system where we have CML readings and thickness, T-min calculations and thickness readings inside of it. We could pull that information from those external sources and actually visualize it directly on the drawing, either with data pods or, again, re-visualizing by coloring or highlighting certain parts of the drawing. That third-party data connectivity is quite broad. So there's a lot of what we call different data silos and sources of information out there. And the fact that we're cloud-based, the fact that we developed this based on the .NET framework, allows us to make use of the application programming interfaces, the APIs, to go out and extract different pieces of information, as I was just explaining in the EAM level, from all of these different sources of information. So again, maintenance, EDMS systems, process data, data historians, inspection systems and risk systems. The platform functionality, and again, if you go back to those first three levels that I was explaining in the previous slide, if we were to break down what the capabilities are on those levels, it kind of looks like this, where we have the smart register that's being fed in from the CAD drawings being processed. And that first step allows us to get all sorts of information about the content and the inventory inside of the drawings. So we understand taxonomy classifications, so asset types and subtypes of the assets in the drawings. Again, that metadata attribute insight, scraping all of the information that we can about the assets from the information we see on the drawings. Generating inventories for piping, piping accessories, equipment, instrumentation, being able to combine instrumentation into different loops, drawing standardization. So we've had instances where, well, many instances actually, where we get drawing sets, and over the years and through different third-party engineering vendors who are making updates and doing redline activities on drawings, the structure of the drawing can become questionable. And you have a lot of instances where you might have multiple versions of the same symbol being used. So I might have 15 or 20 or maybe even 100 different versions of a ball valve. And because everybody's done things differently, it's very scattered and disorganized. And so we can actually recognize that through our inventorying system to standardize on that. So if we want to go and do a find and replace, as an example, on all of the different ball valves and standardize on one single symbol, we're able to do that and then actually write that back to the original CAD file. Asset classification shape libraries is really the foundation for understanding everything that we see in there, understanding which drawings assets occur on. So if you need to do a search for a pump, P600 as an example, we can immediately tell you which drawing or drawings that pump occurs on, which one it's been referenced from. And the EDM drawing classification at the top is really understanding, looking at title block information, understanding what type of drawing we're looking at. Is this a piping and instrumentation diagram? Is it an isometric? Is it a one-line diagram or a marshalling panel diagram? So we can understand that information as well and organize the inventory of the drawings. When we get into the intelligent drawing platform, and this is where we start pulling in information and changing visualizations, it breaks down as you see on the right. So we can do process mapping, again, understanding that flow direction and the connectivity coming from and going to. We have redline tracking, and so we actually have a tool where you can annotate on top, and it actually goes beyond just annotations. We can circle an area and actually understand all of the content that is inside of that area that we've circled. And so, could it represent instrumentation or different valves? If we're replacing a pipe spool, we understand, which flanges and which valves are involved in that operation. The visualization layers comes down to getting information from other systems and being able to visualize that on top of the drawing, again, by recoloring or creating layers on the drawing. So we've had examples where we're identifying asbestos-based insulation and understanding which circuits potentially have asbestos insulation in them, and being able to visualize those on the drawing for understanding when we're going out to do inspection planning, if we have asbestos situations. We've done examples where we've pulled in risk information, and I'll actually be showing that later in the presentation, where we're actually showing risk information and being able to forecast out, based on shutdown or turnaround intervals, what risk will be by recoloring and visualizing that on the drawings. Actionable insights really falls to anything, being able to use information that we've extracted from the IDP together with information that's coming from additional data sources, merging that information together and being able to build reports and KPIs off of that is quite powerful. The customizable data pods is a simple concept, just being able to click on an instrument and being able to see associated documentation or information on that instrument, or a pump as an example, being able to see a maintenance manual or manufacturer's manual on a pump, or photographs of it, or any other sort of documentation that's associated to it. IoT connectivity. So, this day and age, we have many different sensors pulling information from the field, being able to pull that information into the drawings and visualize that real time. Drawing distillation I talked about earlier, with being able to take multiple drawings and distill down a single process inside of those and highlight and visualize that. I'll show examples of that. And then most importantly, mobile and tablet solutions. This is not something that you're stuck at your desk and having to collect information. You can actually take this on a tablet out to the field. So you're standing in front of that pump, you want to see information on it, you do a search, pull up the drawing on it, tap on that pump, and then you can see the information and the documentation in the field from that.